Hey everybody, this is Larry. This is me doing the last weekly problem of the week 4 of the February weekly Leetcode challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. 1259 handshakes that don't cross. It's a hard and it seems like a combinatorial problem because, well, I'm just looking at this thing. There is a mod, so that's mod. Sing any mod songs I don't forget. Okay, so you're given an even number of people. They stand around a circle, and each person shakes hands with someone else, so that there are a number of people over 2 handshakes total. Okay, return the number of ways these handshakes would cross, such that none of the handshake cross. Okay. If I have to guess, not gonna lie, this is just like cheating, experience kind of thing. If I have to guess, this is calendar numbers, right? And the reason why is because just looking at example 2, you can kind of see the idea behind writing this is something like so you have a recurrence that's like I don't even know if I know anymore, right? So like XR or something like that, and then you do for I in range of X, and then you divide it from left to right, and that's the number of things, right? There are a couple of ways to do Catalan numbers. Given that this is 1,000, it's Catalan number. Oh, I think maybe not even right. But basically, maybe I'm mixing the other one. But Catalan numbers is basically you have a function of x, and then now it's a sort of divide and conquer brute force where you're dividing it into 2 things, left and the right, and then you iterate all possibility of it, right? And here you can think about it as and the reason why I jumped to that is just a lot of it is honestly experience. And let me write out the name right now, sequence or numbers or whatever. And you can kind of read it. I mean, obviously in this case it's going to be where number of people over 2, and then that's the calendar number, right? Because that's the number pair. But the idea basically is that, for example, let me actually bring up paintbrush real quick. And honestly, I mean, and this is one of those things that, to be honest, practice and experience will get you stuff like this, right? Like when you, and this is a kind of maybe an extreme example, of course, but basically, like, when you see someone doing even like a simpler thing, and then you ask sometimes like someone really good, not me, if you ask someone really good, you're like, hey, how did you get that so quickly? And then, to be honest, the short answer really is, sometimes they say it's intuition, and maybe they have an intuition, and then they do a little bit of a proof because they don't remember the exact proof, and they don't want to be wrong. They want to be careful. But a lot of it is just experience and practice, and then having this practice and experience means that you don't have to prove it again, right? If you know it to be true, it's almost like an axiom in your book or something like this, right? Anyway, so the idea here is that. Okay, so let's say we have 6 things, right? That's one of the input. The idea is that without loss of generality, we can connect the first one first, right? Because otherwise they're just going to get duped anyway. And then there are really 5 ways of doing it, kind of, right? You'll see why in a second. And you can write the for loop to kind of reflect this, but like I said, I know the answer. Maybe watch me be wrong and be really sad about it. But even if I'm wrong, the idea is still gonna be the same. It's just a little bit it's just like the recurrence is the same. Maybe the base case is a little bit different or something funky. But judging that the second number is 2 and the third number is 5. That's also the other reason. Just to say that as well. I actually do know the first 5 numbers of Catalan sequence, maybe even the 6. So it's like 1, 2, 5, 13, 42 or something like this. Did I make or 14? Sorry, 14. 1, 2, 5, 14, 42. And then I think 132 is the 6th one. I don't know where I got 13 from because it doesn't even make sense. Actually, I guess there's a 5, so maybe it could make sense. But anyway, So yeah, so kind of just, and obviously it's not conclusive, but looking at this one, I was like, oh, this is a 2 and this is a 5. That gives me a little bit more confidence, right? Anyway, the idea is that, okay, given this number, given this node on top, and it doesn't really matter which way, you just drew a brute force line on all of these, right? And that's really the idea. And what happens when you draw a line, right? So when you draw a line, it basically divides, because now you can't draw a line that crosses it. Basically now you're dividing into the left half and the right half. And then now you can almost redraw these into, I mean, this one is impossible, and I did it intentionally because they have odd numbers, right? But in theory, you'll be like, okay, now this is f of 3, and this is f of 1, right? Both of which is 0, it turns out. But in any case, yeah. So basically, now you just multiply all these things together, being like, okay, or multiply the left and times the right, and then you add it to the number of cases, and then that should get you the answer. And that's basically the core idea of it. Let me draw one more case. Oops, I hit something. I don't know what I hit. Let me draw one more case where basically, use a different color. If you draw this one, then now you have 2 on the left and 2 to the right, and of course this is just going to be f of 2 and f of 2. And f of 2 will be equal to 1. Anyway, and I would also say, just to be clear, like, I don't want to make myself sound like I'm super smart or anything like that. This pattern actually comes up relatively a lot. Maybe not like not all the time, but for a sequence, it is actually very common. And maybe the reason is pretty straightforward, as you would think, right? It's because of this. And when I write the code, maybe it'll be more clear. Is that I mean, the structure is just very, I don't know, just very common, or like it's a very natural feeling structure. I don't know how to say it, right? Sometimes, when mathematicians and stuff like that, mathematicians and people that are like drawn to math, and they talk about like sequences and the beauty and all these symmetry and structure. This is a sequence that I consider kind of one of the beautiful sequences for stuff like that. So just one of those things that comes up. It's a recurring theme, right? In any case, but before that said, it's not really that necessary to know that structure or whatever. You can prove it from scratch. It is just divide and conquer and recursion, and that's pretty much it. So I'm gonna go and actually implement it. So let's just say calc x, and here I know that I said you could divide it by 2, and that will be the x over 2. Would be the number of counter numbers. Let's pretend I don't know that for now, and then we could try to figure it out, right? So if x mod 2 is equal to 1, then we return 0, because with our numbers we can't really match them, right? That's the idea. And then now we can maybe say left in range of from 0 to x in increments of 2. I think we don't want to go to x. I think it doesn't go to x. No, I think it should go to x. So yeah, right. And then the right side. Oh wait, no. I see. Yeah. No. Okay. Well, it should go to x. Yeah. Okay. So right is equal to x minus the number of nodes on the left, and then minus 2, because that's the number of nodes that are removed, right? Because you drew the line of that requires 2 nodes. Also, I missed the base case. So yeah, if x is equal to 0, we return 1. So we have this left and we have this right, and then and then we have let's just say count is equal to 0, or just count maybe. And then we have count. We add it by calc of left times calc of right, right? Maybe we do a little bit of a mod, and that's pretty much it. That's the idea. And that's the answer, really. I know that I haven't done the memorization, but I will do it. Don't worry. For those people who are a little bit ahead of the curve. Ooh, did I mess up? Left, right. Did I mess up? I mean, I might have messed up. Because if left is 0, then this should be x minus 2. Do I have a negative number by accident? Let's take a look. Maybe I have a typo. Whoops. Did I miss anything? That is embarrassing every time I do it. Every time I talk about... I spend like 10 minutes talking like, wow, Larry is so smart. I know this sequence, and then now I just can't code. Programming is hard, kids. That is a little bit weird. Did I mess up anything? Yeah, we didn't have any. Let me see. Let's just say this 2. So 2 x is equal to 0. How? That's weird, right? Hopefully I print some stuff before it gives me the recursion. 2, right? So 2, did I mess this up? Is this not supposed to be right? So this gives 0. That's fine. One of them is 0, and the other is 2. Did I mess this up? X minus left minus 2, right? If x is 2, then this goes to 4. Is this inclusive? Did I mess that up? Because this could be, if left is x, then this goes to negative 2. Maybe I just messed this up. This was silly. I didn't really think about it. Okay. What did I do? That is very weird. Alright. Let me think about this for a second. If left is x, well, I mean, it shouldn't go to x. Why did I think it oh, because I thought, okay, I see. Because I thought that right should go to 0, but right goes to 0 when left is 2, or x minus 2. Okay, I'm being dumb, of course. Okay. Anyway, as you can see, this is going to be good. But if you try to want a bigger case, why can't it let me? Okay, there we go. What the one button? Lock myself up. Okay. You know, if you try a bigger case, it'll time out, right? Because this is exponential. It branches with a lot of branching factor every time. So what you actually want to do is memorization, right? Yeah. So how many inputs are there to x? X there are, and it goes to up to 1,000, right? So yeah. So, and each of these, yeah. I mean, if there's only 1,000 input, then we know that we can memorize it because, yeah, there's only 1,000 input. Oops. So yeah, so has cat. Number of people plus 1 maybe. Okay. And then cache is equal to none. Alright, and then now this is just regular caching thing. So we have already calculated this, then we return the calculated value. Otherwise, we do the magical math. We do have cache of x is equal to true, cache of x is equal to count, and that's pretty much it, hopefully. And hopefully I didn't make another silly mistake, but you can see that it looks good here. So let's give it a submit. That's the thing with counting numbers. Apparently I've done this before. I actually didn't remember this. It's a premium question, so how would I have done it before? That's actually surprising. Was this like a contest problem or something? Don't know. I don't know how I would have done this 3-4 years ago because I didn't have premium. Did they make it premium or something? I don't know, right? In any case, I mean, whether I've done this particular problem before, I have done Caroline sequence before, so it's not, you know. And also 3.5 years, I guess it's too long for me to remember anyway. Yeah, so what is complexity, right? Well, x goes to 1,000, and yeah, time complexity is equal to number of inputs times time per input, right? and time per input is going to be O of x because of this loop. So basically this is O of x squared. I don't like using n squared for this because n is not the input, but or n is not the size of the input more specifically. And then O of x space, which, you know, that part hopefully makes sense because there are only x input and each space per input is O of 1, right? That's all I have for this one. Let me know what you think. Let me know what you let me know if you've seen color and numbers before, and let me know if you had fun with this one. That's all I have. Let me know what you think. I said that already. I really care about what you think, apparently. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.